So, yesterday, that was yesterday, we talked about what?
We talked about independent and dependent variables.
Independent, dependent variables,
The
domain and range.
Something else.
Oh, the different ways
Graphs?
to write it too.
To write what?
The
Graphs,
numbers.
how
Oh,
to
the point.
How to express a relation. Very good.
that thing.
So we talked about relations. Yesterday the notes were titled Relations and Functions. We mainly dealt with relations yesterday, so today we're going to get into functions. But yesterday we talked about the ways to express a relation, domain and range, independent, dependent variable. That all ring a bell from yesterday?
Yes, sir.
Very good. So today, let's get into functions. So as you notice here, I got some pieces of mail, and I got some mailboxes. So each piece of mail can go to one mailbox, right? If it wants to, or if someone sends it there. I could even have two pieces of mail go into one mailbox, right? That's okay. Can I have one piece of mail going to two different mailboxes, though? Like, without making a copy, anything like that? No, I cannot. I'm not going to tear a piece of mail in half and send it two different places, am I? No. So that's not possible, is it? So, that's kind of the same thing for functions. Let's think of our pieces of mail as our x values, our mailboxes as our y values. For a relation to be a function, I want each piece of mail, aka each x value, to only be paired with one y value. Does everyone see that? Our y values can have two x values, just like a mailbox can have two pieces of mail or three pieces of mail. But I don't want the same x value to go to two different mailboxes. Does that make sense?
Yes.
So that's kind of just a little visual to help understand functions. So can I go ahead and move on?
Yes.
So, definition of a function. I don't know why that's up there. But function, it says, a relation in which each element in the domain, aka my x values, is paired with exactly one element in the range, my y values. Each x value is paired with exactly one y value. So, a function does not repeat an x value, and the graph must pass the vertical line test, which we'll talk about here in a second.
Is that the definition for a function?
Yep.
Okay.
So at the top it says function, and it's underlined, and it says a relation. That's the start of that sentence. Function, a relation in which each element in the domain is paired with exactly one element in the range. A function does not repeat an x value. That's essentially what that is saying. So make sure we're all writing these notes down. So here's an example right here. We have a relation. This one is a function because what are my x values?
1, 2, 4, and 5.
1, 2, 4, and 5, and none of them are repeating, are they?
Right.
Nope, so that would make it a function.
And if they repeat in their not a function?
Very good. So here's the second example. What are my x values?
1, 2.
1 and 2. Are any of them repeating?
Yes.
Yep, 1 is repeating. It's listed twice as an x value. 2 is listed twice as an x value. So since I have at least one x value repeating, it is not a function.
Is that what our homework's going to be over?
Essentially, yes. Does that make sense? If the x values do not repeat, it is a function. If the x values do repeat, it is not a function. Questions about what a function is? Good? Can I move on, or are we still writing?
I'm still writing.
Okay. Can I erase what I've written and underlined?
Yes.
For it to be a function, no x values repeat. Let's make sure we're writing these notes down. Any questions? Can I move on? So let's talk about discrete function versus continuous function. This first word up here says discrete function. A discrete function is a function that has points that are not connected. A continuous function is a function that has a graph that is a smooth line or curve. So, yesterday we graphed our relations, correct? We had points kind of all over the place, right? Kind of like this. Did we connect our points yesterday? No. So if our points are not connected, then that would be considered a discrete function. Okay? And the domain of our discrete function was just about 4 or 5 values, correct? Just however many ordered pairs we had. A continuous function, so down here, what I have drawn down here would be a discrete function. For it to be continuous, all my points are connected with a smooth line or a curve. So that would be a continuous function right there. It's a nice smooth curve. All my points are on that curve. Or I could have a nice smooth line. That would be continuous as well. So discrete, points are not connected. Continuous, they're connected. It's a smooth curve or a smooth line.
This is kind of off topic, but what did you guys go over in this class last semester?
Ask me in a little bit. Okay.
Because this is the stuff that I did last semester.
Gotcha. Okay. So for our continuous functions, our domain and range is going to look a little different. For my discrete functions, it was just a set number of x values, right? Because I only had that many ordered pairs. For our continuous function, there's an infinite amount of ordered pairs on that curve and on that line. There's an ordered pair there, 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 and it just goes on forever and ever and ever. Okay? So, we're going to see an example at the end of the notes on how we would write the domain and range of a continuous function. Okay? So just be ready for that at the end of the notes. Any questions about discrete versus continuous, though? Discrete, points are not connected. Continuous, all the points are connected with a smooth curve or smooth line. Can I move on? Okay, vertical line test. A graph is a function if a vertical line does not intersect more than once, intersect the graph. If a vertical line would intersect the graph more than once, the graph is not a function. So let's look at our line that we had drawn earlier. So I'm imagining a vertical line going across my graph. That vertical line goes on forever and ever and ever. I always tell students to use your pencil as your vertical line for your vertical line test whenever you're doing it on your assignment. You're going to drag that vertical line across your graph. For it to be a function, I want that vertical line to only hit my graph one point at a time. I don't want there to be any point where it hits it twice at the same time. Does that make sense? So this graph that I've drawn, will this be a function or not a function? It'd be a function, because it's only going to hit one point at a time, right? If I drag this vertical line across my graph, it's only going to hit one point on that line at a time. Does that make sense? Let's look at this graph. That'd be a function or not a function based on my vertical line test? It would be a function. It's still only going to hit one point at a time, isn't it? because it's curving up and it's going up and to the right forever and ever and ever. It's kind of got that gradual slant. Same thing to the left. It's only going to hit one point at a time. What if I give you this? Would this be a function or not a function? Not a function. Because if I draw my vertical line, it's hitting this point at the same time as it's hitting this point.
Yeah, I was like thinking just like a line in general.
Nope, it's got to be a vertical line. Okay? Because think about it, for it to be a function, I don't want which value to repeat? X value. So let's say here, on this one that I have, that this is -2, where it's crossing those 2 points. It's got an x value of -2 here, and an x value of -2 here, so that x value is repeating. And that's why we're able to use the vertical line test. Does that make sense? It's not just any line. It's got to be a vertical line hitting 2 points at the same time on your graph. Yes?
If the line is directly up and down, would that be not a function? Just a
So
straight-
you're saying like this.
Yes.
Correct. Because it's going to hit every single point at the same time at that point, right?
Yes.
Very good. Any questions on how to use the vertical line test to tell if it's a function or not a function? We all right so far with function, not function? Can I move on? You guys tired today?
Yes.
Wake up. So I got a little handout for you. I'm giving you guys one more Ariana to give to AJ.
On top of the assignment. Is this the assignment today?
No.
So we had 2 assignments today?
Huh?
We had 2 assignments today?
No, we're going to go over this together. This would be part of your notes. Make sure you're taking notes. So, one side of this handout that I just gave you has a function and not a function column. The other side has a bunch of relations. You are just going to decide which of these are functions and which ones are not functions. So look at letter A. I've got the ordered pairs 1, 2, 2, 2, 3, 2, 4, 2. Would that be a function or not a function? Function. Why?
Repeating x values.
None of the x values are repeating. So it would be a function, so I'd put letter A under the function column. Does that make sense?
Like,
So take
like,
some,
just function on it. The answer.
flip it over and put A in the function column.
Oh, okay.
Okay? So take some time to do this either on your own or with a neighbor.
What does this do?
Hold on.
Is it fine if it's a long?
Hold on. Let me finish explaining before you start asking questions. Take some time to do this either on your own or with a neighbor around you. I'm okay with that. Y'all need to be only talking about this though, not anything else. Take some time to fill this out and do all of them. Notice on S and T tells you to create your own function and create your own non-function. I do want to clarify something real quick. First hour struggled with this. On these graphs down here, they're kind of hand-drawn, so they're not very good. So this graph on letter M is supposed to be like a smooth curve coming up like this. So that's not a vertical line right there. Okay? And then letter O, same thing. This is supposed to be a smooth curve coming out like that. Smooth curve coming out like that. Any questions?
No.
Who was asking a question over here? You good? What was your question?
Is this due today?
We're going to go over it as a class. This is part of your notes. Okay? So this is not going to be a grade. You still need to do it though. So take some time to work on it on your own or with someone around you. I'm going to pause the recording while we are doing this in class.
Remember to start your report.
Okay, letter A. We already said was a function. You can't see it on the board, but I'll write function on it. Okay, letter B. Raise your hand if you can tell me if it's a function or not a function. Why?
Because none of the top numbers, well, none of the X values would be.
Very good. None of my x values repeat, so this would be a function. Letter C. Someone raise your hand and help me out here.
It's not a function because the fives repeat.
Very good. Not a function. I have x values repeating. My 5 repeats. Letter D.
Not a function.
Why?
Above it has 4 twos.
I have an x value repeating, right? So it's not a function. Very good. Letter E.
It's a function.
It is a function. That's a mapping right there. But that was like our very first example with the letters, the mail, and the mailboxes. All my letters are going to one mailbox, right? I don't have any letters trying to go to 2 different mailboxes. Very good. Letter F, raise your hand. It is a function, same thing. They're all going to one mailbox. Letter G,
Not a function.
not a function. Which one's repeating? 8, very good. That piece of mail, 8, cannot go to 2 different mailboxes, can it? For it to be a function. So this is not a function. Very good. H, raise your hand.
Not a function.
Very good. Which values are repeating?
1 and 5.
1 and 5 are both repeating, so it's not a function. I.
It's a function.
It is a function. None of my x values are repeating. J, someone who I haven't heard from.
Not a function.
Not a function. My 2 value, x value is repeating. So it is not a function. Okay, someone who I haven't heard from. Not a function. Very good. 6 and 5 are both x values that are repeating. L, someone I haven't heard from. Do I have any x values repeating on L? I do not. So is it a function or not a function? It's a function, right? None of my x values repeat. It is a function. Very good. Okay, letter M. Were we able to get that one since I redrew it?
Was that not a function?
It is a function.
That's what I meant to say.
Good job.
Dang it.
It is a function. Like I said, it's kind of hand-drawn on there, so it's not the best graph.
That's why.
But it is kind of going up at this angle. So it is a function. The vertical line's only going to hit one point at a time on that graph because it's got that slight angle on it. Letter N.
Oh,
Not a function.
Mr. McCall.
That graph, the vertical line's going to hit it at 4 points at one time, isn't it? It's going to hit it here, 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 and here. Yes?
I said not a function because I thought you were on in.
Oh, I got you.
Yes,
I got you.
it.
Okay, letter O. Did someone get that one? It is a function. Once again, that vertical line's only going to hit 1 point at a time because those are kind of angled out. David. P.
Oh, I was gonna ask if I could do Q, because I know.
Oh, dang it, I wanted to do.
Okay, P.
Not a function.
Not a function. Very good. We already saw that earlier. Someone asked about that in class. If it's just a vertical line, my vertical line's going to hit every point at the same exact time, isn't it? So that's not a function.
Yes.
Q.
Q would be a function.
Y.
Y equals, so it's the formula of y equals mx plus b. And 3 is, it means up 3 to the right 1, meaning it would never intersect intersect vertically.
Very good. So, maybe you guys remember this from pre-algebra or not, but that is slope-intercept form of a line. It's a linear equation. What's my y-intercept?
2.
Nope.
Or y-intercept?
Y-intercept is 3. What's my slope?
2.
2 over 1.
Oh.
So on a graph, ignore S for right now. I'm just going to draw a graph over here. My y-intercept is 3. So I'd put a point at 3 on my y-axis. My slope is 2 over 1, so I go up 2, right 1. Put another point. I can go down 2, left 1. And that creates a line.
Oh.
You should probably graph it on the big
I
bar.
know what you're talking about.
It just creates a line like that. So that would be a function because a vertical line going through that would only hit one point at a time. Does that make sense?
Yeah.
Now, we haven't covered slope-intercept form in here yet, but you should have seen it in pre-algebra.
Yes.
So that's how you could have gotten the answer to Q. We will cover that more in depth later on, though. Again, since you guys have seen it before. Actually, I'm going to leave that graph there because that is a function, and it says create your own function. So there's my function. And letter R.
Yeah.
It is a function.
It is a function, vertical. It's going to pass the vertical line test. Okay, here's an example of a function on S. Someone else get something different?
Oh, on S?
S.
I just put a U.
A parabola.
Yeah.
So like that.
Yeah.
That works?
Oh, I did the same thing.
Okay. Anyone have anything different?
I just did a lot of ups and downs.
Oh, I think I saw yours. Yours was like a sine cosine wave. Like that, right?
They were pointed.
Oh, they were pointed. That works too.
Well, I was just in college, so it is, right?
Like that, right? Similar to that. That'll work. You could have had a mapping on there. You could have had a table of values where the x values don't repeat. Any of those would have worked. Okay, create your own non-function.
I did like a sideways view.
Like that.
Yeah.
Very good. That's not a function. It's not going to pass the vertical line test.
I made one of the little circle map chart thingies.
Oh, mapping.
Yeah.
What was in your x column?
1, 3, and 2.
1, 3, and 2.
And then I had 8, 7, 6, and 4 in the other one.
8, 7, 6, and 4.
And then 1 and 3 were forming to 8 and 7. And then 2 was forming
Like this.
No. 1 and 3 were pointing to 8 and 7. And then
So 1 goes to 8,
yeah.
and 1 goes to 7.
Yeah.
And
No, 3 goes to 7. And then 2 goes to
so 1 goes to 8.
Yeah.
3 goes to 7.
and then 2 goes to 6 and 4.
2 goes to 6. 2 goes to 4. Very good. That's not a function. Very good. You could have created a table of values where you had an x value repeating. That would have worked too. Any questions on function, not a function? We all good there? Okay. There's all our answers once again. Our functions, not our functions. We already went over those. So, here is one of our continuous functions. It's a smooth curve. It says find the domain and the range. I told you it's going to look a little different, didn't I? So I'm not able to just list the x values in my ordered pairs because I have an infinite number of ordered pairs on this line. So if I try to list all the x values in my ordered pairs, I'd be doing this problem for the rest of my life. Okay? I'll do what?
I said maybe.
Maybe. What do you mean maybe? You'd be doing it for the rest of your life. Yep.
And then whenever you die, you would never be finished.
So, I've got to represent it another way. I'm going to be using that set builder notation I used yesterday for my domain and range. I have my domain is the set of all real numbers x such that now for my x values, my domain, I'm looking at my horizontal numbers, my horizontal axis. So what's the smallest x value that's on the graph? Negative 4. Negative 4 is my smallest x value, correct?
Yes.
Since that's a closed dot, you think negative 4 is included in the interval or not? If it's a closed dot. It is included. So I could get negative 4. Oops, that's the eraser. Negative 4 is less than or equal to x. What's the biggest x value that's on my graph? 2, right there. It's a closed dot, so is 2 included? There's my domain right there. Does everyone see that? It's all the x values between negative 4 and 2. All the real numbers x. And negative 4 is included, 2 is included. So I have to use the less than or equal to signs. Now let's do our range. Range is a set of all real numbers y, such that now I'm looking at my vertical numbers, my vertical axis, the y-axis. What's the smallest y value that's on my graph? 2. Because it would be this value right here, correct?
Yes.
Is that value included in the interval? Yep, because it's on that line, right? Or on that curve. So 2 is less than or equal to y. What's the highest y value? 6. Right here, right? Is that value included? Yep, so less than or equal to 6. There'd be my range. Does that make sense?
Yeah.
Let's look at another one. Find the domain in the range. Okay, so we're going to be using our set builder notation again. The domain is the set of all real numbers x such that, can someone help me out on this one?
Oh, yeah, Paul, yeah.
Yes.
So it would be 6. Wait.
Looking at my x values, the horizontal axis.
Oh, okay.
So what's my smallest x value?
0. Or 2.
2.
Sorry, I was confused for a second. Is less than or equal to? Less than. Oh, okay.
Does everyone see why it's just less than?
Yeah.
Because it's an open dot, so 2 is not included. So it's all the numbers up to 2, but not including 2. Okay? What's my biggest x value?
6. No, 8. 7.
7. Is 7 included?
Yeah. No.
No, because it's still an open dot. So it's all the numbers up to 7, but not including 7. So there's my domain for that one. Does that make sense? Okay, let's talk about range. Set of all real numbers y, such that, what's my smallest y value that's on my graph?
3. Wait, no, yeah, 3. 4.
Looking at my vertical, I heard someone say it. 1. Is 1 included?
No.
No. So it's just less than, not x, y. What's my biggest y value? 6. Is 6 included? No. So there's my range. Does that make sense? We have to do it this way so it can represent all the numbers that are in the domain and range. When we had our continuous function, we just had ordered pairs graphed, right? Like this. So we only had 4 x values there, right? And 4 y values. Here, I have an infinite amount, so I have to use it as an interval. Does that make sense?
Yes.
Any questions about function, not function, domain and range of a closed or continuous interval? Here's our assignment.
It just says practice.
Page 109 to 110, numbers 3 through 17 all. Yesterday's assignment, I think I told you guys, was due today. I got that posted really late last night, so I pushed the due date back to Monday.
Wait, 3 through 10 or 3 through 17? You said 10.
I said page 109 to 110, numbers 3 through 17 all. So this assignment will be due Tuesday, February 9th on Canvas. If you've already finished yesterday's assignment, you can turn it in on Canvas. But this one will be due Tuesday. So make sure you get this written down. I'll pull the book page up for a little bit. We have a little bit of time left in class, so don't start packing up yet. Get paper out to get working on the assignment. So get this written down so I can get the book page pulled up. Any questions before I end the recording?